Welcome to another video here for chemistry. This one's going to be on the mole and mole to atom conversion problems. This is going to be a quick introduction to the mole, quick talk about what the mole is, and also going to show you guys how to do some practice problems for worksheet number 1. So let's get into this here. So what is a mole? Well, a mole is not the furry little creature or furless little creature if you're talking about naked mole rats. Kim Possible. But it is not the little creature that we're talking about here. It is not the ugly little thing on somebody's back or anywhere else on their body. It is actually a unit of measure. Just like the word dozen is a unit of measure, a mole is a unit of measure. So when we're talking about a dozen, we usually know that that is going to be 12. 1 dozen is equal to 12 eggs. If I buy a dozen eggs, I've got 12 eggs. Right? So when I'm talking about a mole, it's the same concept. It's a certain value. It's a certain amount. So it's a unit of measure, just like the word dozen. A dozen is 12. A mole is also a certain amount of something. And we're going to take a look at what that value is today. What are we measuring? Well, we're actually measuring particles. And a particle could mean an atom, a molecule, or a formula unit. We're going to spend our time looking at atoms and molecules. So what does a mole equal? Well, we said 1 dozen was equal to 12. So if I buy a dozen eggs, I have 12 eggs. Well, when I'm talking about 1 mole, I'm actually equaling this to 6.02 times 10 to the 23rd. Now you guys have to remember that this is in scientific notation, and this is a gigantic number. It is just a huge, huge amount here, right? I can write it out for you really quickly. Oh, not what I want to do. Write it out with a different pen here. Write this out here really quickly just so you can see how massive this is. 602, and then I've got 21 zeros. 21 zeros after that thing. That's a huge number that we're talking about. So 1 mole is equal to this gigantic number that we're looking at. So we always express this in scientific notation. 6.02 times 10 to the 23rd. Now, again, we are talking about particles of a substance. The reason why this number is so large is because we're talking about something that is so small. We're talking about molecules or atoms of a substance. We're looking at individual tiny little particles that make up matter. So when we say 1 mole of something, we mean 6.02 times 10 to the 23rd particles. Now those particles could be molecules or atoms, and we'll take a look at how that works. Now, whether I have molecules or atoms depends on what I'm actually going to take a look at. If I have an element of a substance, 1 mole of an element, remember 1 element is 1 type of atom. So when I have 1 mole of carbon, I'm looking at one thing, carbon. Well, that means that I have this 1 mole of carbon that's equal to this many atoms of carbon. When I have 1 mole of sodium, it's the same thing. It doesn't matter that I have carbon here and sodium here. 1 mole is always equal to this value, 6.02 times 10 to the 23rd. But the big thing is, when I have an element, an individual atom, one type of atom, like carbon or like sodium, my mole is always equal to this many atoms of that substance. When I have a molecule, this is 2 or more different atoms. Like in this example, I have H2. When I have a mole of a molecule like this, my value is going to be 6.02 times 10 to the 23rd molecules. So a mole is actually going to be equal to 6.02 times 10 to the 23rd always, but when I have more than 1 atom here, it's going to be equal to that many molecules. Here I have sodium chloride. I've got more than 1 atom here, so a mole of sodium chloride is going to be equal to 6.02 times 10 to the 23rd, but it's going to be equal to molecules this time, again, because I have more than 1 atom. So how are we going to use this? Why are we talking about this mole substance? Well, the mole is actually crucial when we are talking about how to convert from one thing to another in chemistry. This is a flowchart that you guys are going to get today. This flowchart is going to be really important for this entire unit that we're taking a look at. And right in the middle of this flowchart is the moles, right? Oh, that's kind of a graphic drawing. Anyways, what we're going to take a look at here, we say that the mole is the heart of chemistry. Beautiful heart drawing. because a mole is what we need to convert to go from one thing to another. It's very, very important for what we're going to be doing in chemistry with this. So you guys are going to be using this flowchart quite a bit when we go through this. Now, this is a big, nasty flowchart, and what we're going to do is actually, for the beginning of this, we're going to fold it right in half. So I want you guys to do that. Take your flowchart and fold it in half. And we're only worried about this left side of the equation right there. That's the only part that I'm worried about. So I want yours to look like this when you guys are done with this. We're going to use this. We're going to use the mole. We're going to do some practice problems and see how we can use this. All right, let's start out with a couple examples. Number one, it says how many atoms are in 3 moles of aluminum? I don't want you to freak out with these problems. The big thing to remember, guys, is that you should treat these problems just like all the other problems that we did when we did the factor label method. We want to set them up the exact same way that we did before. Take what I was given and put that value over 1. So I'm going to take what I was given. I was given 3 moles of aluminum. Let me rewrite that. Kind of off on my game here. 3 moles of aluminum, and I'm going to put that over 1. We've done that for every problem we've done so far this unit. We're going to keep on doing that for the rest of the unit. Just like I was doing before, I'm going to take whatever my units were up here, and I'm going to move them down here. So I have moles of aluminum up on the top there. I want to put moles of aluminum down here. This has got to come down there. The units have got to come down. Do not bring the number with it, just bring the units. All right, now what's my conversion factor? We've done all these problems before, and we always had a conversion factor to go from moles of one thing to something else. Well, we have it. We have it right here. This is my conversion factor now. So we're going to use this flowchart to take a look at this. And in here, we zoom in on this, it says that 1 mole is equal to 6.02 times 10 to the 23rd molecules, right? And that's what we want to take a look at. So that's the conversion factor that I'm going to use. 1 mole is equal to 6.02 times 10 to the 23rd molecules. So what does it say? Well, 1 mole is equal to 6.02, got the wrong pen on here again. 1 mole is equal to 6.02 times 10 to the 23rd molecules. So what I'm doing is I'm taking moles and I'm changing them to molecules of aluminum. My moles will cancel out, and now I'm in molecules. I got to keep going because they asked me to go to atoms. So I've actually got to use this flowchart and keep going. Here was where I started. I started at the mole. I used this conversion factor to go from moles to molecules. So I used this conversion right here to convert from moles to molecules. Now that I'm in molecules, I got to take one more step here to get to the atom. So now we're going to take this extra step here. We're going to go from molecules now to atoms. Well, how do I do that? This is how you do it. The conversion factor is right there. This is one that you're going to have to calculate. It's not always going to be the same value. It's not like it is with a mole. A mole is always equal to 6.02 times 10 to the 23rd. Well, when I'm converting molecules to atoms, I actually have to calculate this out. So watch how I do this. Hey, set it up the same way we've been doing it with all the other problems. Whatever unit I have up here, that's the one that's going to go down here. So I want to write down molecules of Al because I see them up here. I got to have them down there. They've got to be there. Whatever unit was up on top there is the unit that I have to have down at the bottom in my next step. So molecules of Al are going down to the bottom. Well, what am I trying to convert to? I'm trying to go from molecules to atoms. So I want to put atoms of Al up on the top. Well, how do I do this? Well, it says one molecule, or one molecule of the substance, is equal to the number of atoms. Well, how many atoms do I have? Well, it tells me to count the atoms in the formula. Well, what's my formula for aluminum? Well, aluminum is just Al. That's it. There's nothing else there. How many atoms do I have there? Well, I have one Al atom in my formula. So one molecule of Al is going to be equal to one atom of Al. That's my conversion factor on this. You have to look at the formula to do it. Molecules are on the top, molecules are on the bottom, and now I want to do my math. So how do I set up this math problem? Well, do it the same way we've been doing all the other problems that we've done before. Take the values you have on top, 3, 6.02 times 10 to the 23rd, and 1, and multiply those together. 3 times 6.02 times 10 to the 23rd times 1, put that on the top. Do the same thing for the bottom. On the bottom I have 1, I have 1, I have 1. I'm going to multiply 1 times 1 times 1. When I do that, my bottom is going to be equal to 1. When I do this, my top will be equal to this. 1.806 times 10 to the 24th. And that's my answer. It's that many atoms of aluminum. Let's take a look at another example. In this example, I have 10 moles of water to start out with. That's what I want to take and put over 1. 10 moles of water. Take it, put over 1. Always, every time, all the time. Got to do it. Just like that, every time, all the time. Whatever the units I have up here, they got to go on the bottom of my next step. Moles of H2O are going down on the bottom. All right, let's use this flowchart. Let's figure out how to do this time. Now, I am using this flowchart. This is how I do it. I'm starting out here in moles. I want to circle. Where am I at? I'm in moles. What do I want to go to? I want to get to atoms. I got to get all the way over here. So what do I need to do? Well, I need to follow this path to get there. So how do I have to convert this? Well, I got to go moles into molecules first. So that's the conversion that I'm going to have to do. I got to put molecules up on top here. I got to take my moles and convert them to molecules of H2O. That's what I'm doing. Well, how do I do that? Well, in order to do that, I got to look at this conversion factor. 1 mole is equal to 6.02 times 10 to the 23rd molecules. That's the conversion factor I'm going to use when I'm making this conversion. So let's take a look. 1 mole is equal to 6.02 times 10 to the 23rd molecules. Moles, top, bottom, cancel out. Now I'm in molecules. I got to keep going though because I got to get to atoms. So how do I do this? I got to use this conversion factor now to do this. My molecules are going into atoms. Here I go. How do I do this? Well, it says that 1 molecule is going to be equal to the number of atoms in my formula. So how do I do this? Make my conversion factor. Multiply by something. Whatever unit I have on the top here, it's got to go down to the bottom. Molecules, down on the bottom. What am I converting to? Well, I'm going from molecules into atoms, so my atoms are going to go on the top. Atoms of H2O up on top. How do I do this? Well, it says 1 molecule of this, 1 molecule of H2O is equal to the atoms in my formula. Well, how many atoms do I have in my formula? I got H2O. Well, look at this. I've got 2 hydrogens. How many oxygens do I have there? Well, if there's nothing written, I always have 1. So for oxygen, I have 1. How many atoms do I have in my formula? I've got 3. So 1 molecule is equal to 3 atoms. That's where my conversion factor comes from on this. You've got to count the number of atoms in your formula to convert molecules to atoms. Let's cancel out the parts that are the same. Molecules are on top and bottom. Now we can go ahead. Let's do that math and let's figure out what we get. I've got 10, 6.02 times 10 to the 23rd, and 3 on top. Multiply them together. 10 times 6.02 times 10 to the 23rd up on top. Multiply that by 3. Take that. Put it all over 1. So I've got 1, 1, and 1 on the bottom. 1 times 1 times 1. I will have 1 on the bottom. And when I do my math, when I multiply 10 times 6.02 times 10 to the 23rd times 3, up on the top I will have 1.806 times 10 to the 25th. Take that, divide it by 1, and you will have your answer. You will have 1.806. Oops, I should change colors. 1.806 times 10 to the 25th atoms, and don't forget your units, of H2O. Let's keep it going. Alright, let's do this problem here real quick. We'll do this, we'll do one more, and then we'll be good to go. Now, again, do it just like you've done every problem that we've done thus far. Take what you're given, put it over 1. I was given 4 moles of carbon. 4 moles of carbon. Put it over 1. I have to look at this flow chart. Here I am. I'm in moles. What do I want to convert to? I want to go to atoms, right? So I got to follow this flow chart. My moles, we got to go to molecules. My molecules, we got to go to atoms. I've got to do this and set it up just like we've done all the time. Make my conversion factor. Whatever unit I have on top here, it's got to go on the bottom of the next step. Moles of carbon, next step, on the bottom. Well, what am I converting to? I'm taking my moles and I'm going to, in my first step, molecules. How do I do it? My conversion factor is right here. 1 mole is always equal to 6.02 times 10 to the 23rd molecules, and this is molecules of carbon. Putting that on the top. I've got moles of carbon on the bottom and on the top, so I can cancel those off. Now I've gone from moles, change it to molecules. I am currently in molecules. I've got to take the next step. My molecules that I'm in right now, I want to convert them to atoms. So I want to take another step. Got to multiply by another conversion factor. Here we go. Molecules are up on top. And I want to just make sure that you guys get this. This is molecules. Molecules have got to go down the bottom. Molecules down on the bottom. How do I do this conversion factor? This is it right here. 1 molecule is equal to the number of atoms in my formula. So 1 molecule of carbon is equal to my formula. What's my formula for carbon? C. How many atoms do I have there? Well, I only have 1. There's 1 atom of carbon in 1 molecule of carbon. It's just only one thing there. It's a single element, so there's only 1 atom there for carbon, a carbon molecule. My molecules cancel off. Now I can go right to atoms and I can do my math. Up on the top I have 4, 6.02 times 10 to the 23rd, and 1. So up on the top, 4 times 6.02 times 10 to the 23rd times 1. That's my top. Down the bottom, again I have 1, 1, and 1. So on the bottom I have 1 times 1 times 1. My bottom will equal 1. My top, I got to calculate that out. So now I want to do all this math right here. And when I do that, I get 2.408 times 10 to the 24th. And this is going to be atoms of carbon. Alright, one more, last one, and we're moving on. Let's take a look at this. We're starting out with 2 moles of aluminum carbonate. I've got to write that on here. 2 moles. And I'm using the formula for you guys. You should be able to get this formula from the name. I gave you the formula for it, but you guys should be able to get that formula on your own from that name. Al2CO3 3. That's aluminum carbonate. 2 moles of that over 1. Now, I'm going to have to do some conversion, so right away I'm multiplying and I'm drawing my line, and right away I know, because it's every time, all the time, whatever units I have up on top here, they've got to go on the bottom of the next step. So my moles of Al2CO3 3 have got to go on the bottom. Now I got to use this flowchart to help me out, because I got to get to atoms. Here I am. I'm in moles. I got to get to atoms. So my first step, however, is to stop at molecules. And once I've gone from molecules, then I can get to atoms. But I've got to make this conversion to molecules first. So my 1 mole is going to be converted to molecules. This is the conversion factor. 1 mole is equal to 6.02 times 10 to the 23rd molecules of Al2CO3 3. Now, I'm not done because I got to get all the way over to atoms. My moles cancel out, and right now I'm stuck at molecules. Got to take that extra step to go from my molecules now to my atoms. Let's do it. Multiply by conversion factor. I'm going to have to do my molecules on the bottom. I'm going from molecules to atoms. I'm going to put atoms up on top. I've got to, it says, count the number of atoms in my formula. So let's make a little list. I got aluminum, carbon, and oxygen. I've got 2 aluminums here. When I look at my carbon, it's in these parentheses. So you've got to distribute this 3 in here. That tells me I have 3 carbons. Same thing with the O. It's in the parentheses. I got to distribute this 3 in there. But there's a 3 there already. You got to multiply those 2 3's together to get your number of oxygens. I have 9 oxygens. Now add this up. 2 plus 3 is 5, plus 9 more. I've got 14 atoms here. So 14 atoms in one molecule. So 14 atoms for one molecule. That's my conversion factor. One molecule has 14 atoms. Now do the math. Multiply everything on the top. Multiply everything on the bottom, and we'll be good. 2 times 6.02 times 10 to the 23rd times 14. 2 times 6.02 times 10 to the 23rd, times 14. That's my top. Down on the bottom, 1, 1, 1. 1, times 1 times 1. My bottom is going to be equal to 1. My top, when I multiply that all together, I get 1.6856 times 10 to the 25th. And I'm talking about atoms of Al2CO3 3. That divided by 1 gives me my answer. That's my answer right there. 1.6856 times 10 to the 25th atoms of this. Hopefully you guys can pick this up and go through this and do this. These videos will get posted onto the Moodle. You guys can check them out. And we'll be going through this in class to help you guys out as well. And that is all for now. We'll catch you later.